The title of the next paper is a partial software update on the AURX TC397 platform. This paper has 4 authors. The authors are from Croatia and Serbia. And the presenter is Barbara. Okay, please.
Hello everybody, my name is Barbara and today I will talk about partial software update. Due to rapid development of the automotive industry and autonomous driving, the need for the implementation of different embedded systems within the vehicle has significantly increased in the last decade. Current embedded systems in automobiles control event data recorders, anti-lock brake systems, emission control, etc. The partial updating increases flexibility and adaptability of the software, which allows its modifications in the system which are already deployed to the target platform. So on this slide, you can see the block diagram, which shows the process of obtaining an executable file for partial software update. The partial update is developed on the MotionWise platform. The software is written using the C programming language and developed according to the AUTOSAR standard on the development board with AURIX TC397 Infineon microcontroller. Once all necessary files have been created, the linker is called. The linker is used for connecting all of the files that are necessary for the process of creating executable files. Then, for loading the executable file properly, MEM tool is used in combination with the device called Miniwiggler. MEM tool was used to select a target device on which the executable file is loaded, and Miniwiggler is used for flashing the executable file on the board. The board is connected to the computer using UART, and when everything is finished, the message is sent to UART and displayed on the interface. In few next slides, I will speak about steps of proposed solution. So the initial step in the proposed method is to create empty files. The created files are initially empty and the particular functionalities will be added in the next steps. This procedure was chosen because it was intended to ensure that the files were added in the correct directory and to check that the data of newly created files were defined and written properly. Then the second step is the process of building an executable file. You can see on this picture that the build status is succeed, and you can also see that you can see start time and finish time. So construction of the executable file is approximately 57 minutes. Because a very large amount of libraries and components are linked and compiled. Then, in the next step, a function for printing the data on the serial interface is implemented within the empty.c files. One C file is used for function A and other one is used for function B, while the necessary .h files are included. Then, after adding the code to the source files, the second process of building a new executable file was performed to check the performance of newly created function. You can see on the picture that each function sends the textual data via UART serial bus, specifically the name of the function and its version. Both versions for the functions were 1.0. Then function A is chosen to represent control function and remains unchanged, while the function B is one over which changes and updates will be made. The modification of function is manifested in a change of its version. The version of the initial function was 1.0, and after the update version is 1.1. To shorten the time needed to build the executable file, only a reserved part of the memory will be used. That's one colored in a pink reserved partition. Instead of all available memory. Therefore, a new partition is created in which a new build file will be loaded. A partition represents a reserved memory whose size is allocated by defining a range of memory addresses. As it can be seen from a figure, a newly built file of function B will be loaded on the created partition. The next step is creating new linker and build.cmd scripts because predefined scripts carries information about the memory addresses of all components, and we want to use just a chosen one. The new linker script takes into account only part of the memory where the function B is located. Okay, and finally, the last step is creating the third build and flashing the executable file on the test partition of the port. Time required for building an executable file with partial update equals 9 minutes and 45 seconds. That's 6 times shorter than usual one. Testing the results of a proposed solution. First testing is a testing a partial software update is based on the time it takes to build an executable file. So you can see the table. On the left side is time required to build the executable file without partial update. And on the right side is time required to build the executable file with partial update. The normal construction of an executable file is approximately 6 times longer than one with partial update. The next phase of project testing determines the average time it takes for the executable file to be deployed on the port. The analysis of the data obtained by the experiment calculates the average time required for the implementation of executable file, and it's equal to 99.75 seconds. The standard deviation of the time required for code implementation on the board is 2.3 seconds. Based on calculated normal distribution, a graphical representation of the obtained result is shown on this figure. The partial software update in development phase is very attractive topic in automotive world. In addition to being applied to automotive industry, the concept of partial software update can also be applied in other manufacturing sectors, which are dealing with embedded systems. The reason is to save the time necessary to test the entire software and thus shorten the time for delivery to end users. The standard build time of executable file is 57 minutes and 6 seconds, while the build time of executable file with partial update is equal to 9 minutes and 45 seconds. It's evident that the proposed concept of the solution reduces the time required to update the whole software. So thank you for your attention.
Okay. Okay. Thank you. The excellent presentation. Thank you. Any question or comments from the audience? Any question or comment? So I have a simple question. In your study, so by using the proposed partial software update technology, the design, the design or the execution can 6 times can 6 times faster more than the previous design. So this is a very good job. So how about compared to the if we compare I'm sorry, if you compare with the other design, what is the besides the performance has 6 times faster, what is the other advantage of your design compared to the related work? Thank you.
Because when we use partial update takes into account only those part of the memories on which change were made. That's the main reason why it's
okay.
It's shorter.
Okay. Okay. Thank you. Thank you very much. So
You're welcome.
Okay. Thank you. So any other question or comment about this paper? Okay. If no any other question, I would like to thank the presentation again. Thank you. Thank you, Barbara. Thank you.
You're welcome.